Now that we have a few blocks and that we are able to create blocks via the script, we can start looking at moving into the world. So what I want to start with for this episode is removing all the blocks we have created manually by drag and dropping the scene. So these blocks will be gone, and we will change the block creation, okay, so that we do create a ground for the player to move on. So here I will just create a method which will be initialize ground, very simple. And I will run through a set of X and Z iterations to create a rectangle or a square. So for X, which is going in range of -10 to 11. So the reason why I say 11 and not 10 is because the last one is not counted, right? So it's going to go through -10 to 10 because exclusive. And we will do exactly the same for Z, so in range of -10, 11. And what we will do here is just create a block. So we'll have a variable position as a vector 3, which will be equal to vector 3 x 0 z. Okay, so now we can create a block which is going to be materials one and position. Okay, so we will have a big rectangle. Well, actually no, because I didn't call on the method, but let's initialize the ground, and there we go. We have a big stone rectangle. So what I will do, just for the sake of the fun, I will just add a random variable which will define if we do create stone or dirt. So this isn't really the point of this episode, so I'm just going to go very quickly for that. And now we have a ground which is a mix of dirt and stone randomly. So the entire point of this episode is to create a player. So let's create a new scene, which is going to be a character body 3D. It is a 3D physics body specialized for characters moved by script. This is what we're doing. We are moving the character with the script by pressing some keys. So we do need to create a collision, I believe. This node has no shape, so it can't collide or interact with other objects. Exactly. So we're going to add a collision object, collision shape, which will be a simple rectangle. Okay, a rectangle of 1.9 meters high. And what I want to do as well is to move that, not the size, but the position actually. I want to move the position of this shape, right, so that it is above the ground and not half in it. Okay. I will also add a shape to it. So it's going to be a mesh instance 3D, which will be a rectangle as well, 1.9, and we are moving it to match the collision shape. So there's a slight difference. Okay, that's interesting. Oh, because that's 2. Yeah, I wanted it 1.9. So now there's, again, a slight difference. So let's just fix the transform. So let's have 1, size, transform, 1, so we're good. Okay. This is our character. So now what we need to do is, well, first we will save it. We will add it to the world. That would be interesting. And then we will take care of the controls. Okay, so let's add it to the world so that we can see the character. Just drag and drop it in there, and there we go. So now we should be able to start and see the character right in front of us. Now that we do have the character, let's actually take care of the movements of that character. So we're gonna add a script and make sure that we do add the template for character body 3D basic movements. This is the Godot built-in movement script that we can just add very easily. So let's start simply by typing variables, giving a name to this class as well. Okay, what do we have here? We have delta float. Okay. Here we have nothing to change yet. Here we have untyped variables. So this first one, it's a get vector which returns a vector 2. Okay, so that's going to be a vector 2. This one is a multiplication of a vector 3, so technically it will return a vector 3. If direction, I do like to have spaces before these semicolons, so I do add those. Okay, else space as well. And I do think we are good. So technically we can just save this and again run the game, see that the character is falling, and by using the arrows we can move it and eventually make it fall down. So moving with the arrows is very inconvenient, so yeah, that's the first thing we will do. Do we want to go through that script? Yes, let's see what is happening in there. We don't need to understand everything fully, right? Like, unless you want to have a custom movement system, but that's not what we're doing, so it's great to have this. So first, if it is not on the floor, we want to apply gravity and have it fall down. So that's pretty simple, really. We just want to apply the gravity here. We change the velocity, which is, let's read the description of that. It is a current velocity vector used and modified during calls to move and slide, right? So basically know in what direction you're moving with that vector. So when you're on the ground, your velocity is 0 on every side, and when you are in the air, you have a velocity which is a negative y. So here we have the first input, which is handle jump. So if there's an input which is an action just pressed, and here it is UI accept, and that we are on the floor, we want to increase the velocity y-axis to be in the positive this time by 4.5. Okay. Then we do grab the vector of the directions. By using 4 cardinal directions, we get a vector 2, which is an xz vector, which we will transform into a vector 3. And then we compile everything together to create a final velocity vector, and we just apply move and slide, which moves the character. So here what we want to do is change the control. So in order to change the control, we first need to set new controls. So let's go in the project settings and find the input map tab. Here we can create controls, and we have none yet. So let's just create one, which is going to be jump. So we add this control. When it is here, this is the name that will be used as a reference by the script. And here we can assign different kind of controls that will work for it. So here we want, for example, the space key. Okay, so that jump is going to be space. Now we can go with the movement. So we will have move forward, move left, move backward, and move right. Now we just need to assign some keys. So here for me, it's going to be Z, left is going to be Q, backward is going to be S, and right is going to be D. Now, as you can see, Z and Q kind of autofix, so it's actually quite interesting that Godot does that. So I guess there's a kind of built-in understanding of ASCII and QWERTY, so it's supported. That looks great. Okay. So anyway, here now that we have created those inputs, all we have to do is just replace those which are referenced here. So here we will have jump, and there it's actually very important to respect the order, because if you watch this get vector, we have negative x, positive x, negative y, etc., etc. So it's very important that we do respect those left, right, if we want it to happen to be working well. So we'll have move right, forward, and backward. So I'm just gonna I'm gonna break this line because it's a little bit big. So we have move backward and we're right. So now we just have to go back to the world, start our game, and see that the character is moving by pressing the letter keys and not the arrow keys. And we can now jump, and yeah, that's cool. So the only problem left is that the camera is fixed. So we want to add the camera to the player. So here, as you may remember from the first episode, the camera is supposed to be unique in the viewport. So we need to make sure that we have only one camera active at all times. So we're just going to remove this one. Going to delete it. And we will just add it to the character scene. Because technically, there's not going to be several characters. Well, for multiplayer maybe. But we are not dealing with that, and those are going to be different character scenes, because for example in multiplayer you don't want to be moving other players' characters, so anyway it's going to be a different scene. So yeah, let's just add the camera here, and let's move it up so that it is around the head of our character. So now if we do go back to the world, yeah, we do see that we kind of, well, we'll see the character, which is not really a good thing, and that is actually happening because the camera is outside of it, so we just have to lower it a little bit so that it is inside the block. Okay. And now, since the camera is inside it, the vision, the texture of the block is going to be invisible because we only see the outside texture and not the inside. So now the very last thing we need to do is just to make sure that moving the cursor is actually moving the camera. So this will happen in a script here, and yeah, we will have to take care of a few lines in a new method. So why it could make sense to add the camera controls with the movement controls, we will not do that because this is the physics process method, and we don't want to be taking care of the controls for the camera in there. There's a reason for that, and the reason is that, for example, when you are in a menu, you don't want the camera to be moving around, right? While you are browsing your inventory, you don't want your character to be turning around itself. So we will use another built-in function, which is unhandled. Well, that's a difficult word. Unhandled input. What this does basically is grab any input which has not been consumed by another element. Which means that if it is not consumed by the inventory screen being in front of the game, then it will be read here. So what we do is grab the event, which is arriving here, and we do want to make sure that it is an input event mouse motion. This input event mouse motion has a relative property which we can use, and that relative property has technically an x and z value because it is a vector 2. So here it's going to be a little bit tricky because since it is a vector 2, we will have x and y, but we do have to apply those to x and z because of the 3D axis being different. So back to the function. What we want to do is when we have a x movement on the 2D space, we do want to have a horizontal movement of the camera, and that happens by moving the green circle, which is the y. So the result of that is the rotation dot y being modified. So since we just modify it, we take it again, and we just remove the relative x from the event, and we will use a new method, a new property, sensitivity, which will be used to kind of control how fast we want the camera to be rotating. So the in-game result of that is that we can see that moving vertically is moving the camera quite fast, so we could change the sensitivity a little bit. And now we will take care of the vertical movement, and there's a slight thing we don't want to do, and that is moving the entire character, if that makes sense. Like, we don't want to move the character on the dead axis, or is it? Yes, it could be it is the x actually. Yes, it is the x axis. We don't want to do that. We just want the camera to be moving around, right? This camera here. We want this one to move. So we will have to move only the rotation of the camera for this one. So first, of course, we will need to get access to the camera. So let's make it unique so that we can access it easily. Or we could do it down the way, which is just using a already valuable camera that's often simpler. Camera 3D. And here we will grab the camera. Okay. So in this logic again, when we are on the 2D space, we have the y-axis, which is moving the red, so x-axis, so y becomes x. So the camera rotation is becoming the camera rotation transformed with the x rotation. That's a little bit annoying, that doesn't autocomplete, but an event relative y with this sensitivity. Let's have it a little bit slower. So now we have another problem, which is not very obvious at first, but it does become obvious later. It is that we can technically rotate without limits. So we can, yeah, be looking backward, which is not what we want. So we have to clamp the values of the camera rotation. And fortunately, there's a clamp method. So camera rotation dot x will be clamped. I don't know how you say that, but anyway, between two limits. So this is how the clamp function works, really, right? You get the value, and then you set a minimum and a maximum. So here we will have a degree to radiant minus 90 and degree to radiant plus a 90. Okay. And that's pretty much it. Now if we do go back to the game, we can see by actually running the right scene that once we are looking down, we are kind of blocked. So we still have the very last issues of the mouse being free, which is not what we want. So that's a very simple fix. We could add this to the player, but technically, yeah. Ultimately, that will be the user interface deciding this. So maybe we will set that in the world. Here we do want just to change the mouse mode. Okay, so basically Godot has a mouse mode property, which is handling how the mouse is supposed to be working. So we have captured, confined, hidden, hidden visible, etc. So here we do want captured, right? That it is the mode for this kind of view that we're working with. So yeah, we just have to run the game like this, and there it is. We can move around, we can jump. Turn the camera, we are locked if we do look downward, and same thing upward. And that's pretty much it. That's the very, very, very basic movement for a character, and eventually you might want to get rid of that shadow at first by just going back to the player and removing the mesh instance 3D. So technically here we're just removing the visual aspect of a character. It still exists as a collision shape, so it won't fall down through the ground, right? But it won't cast in this shadow. Okay, so shadow's gone. That's all we will be doing in this episode today. So thank you for watching it. If you did like it, think about doing all the YouTube algorithm things, and yeah, if you want to support the channel a little bit further, we do have the coffee links, and very soon we will have member subscription, because we will have member only videos in this series, which will be, no worries, non-mandatory videos, which means that the member only videos will be, you will not need those to go forward in the series, if that makes sense. In the sense that it's luxury features more than core features. So yeah, that's pretty much it. So you keep practicing game dev, this is how you get better, and I will see you in the next video.